Hi and welcome to another episode of Type with me. In this episode we will learn how to use tensorflow.js within node.js and how we can do machine learning. So on the previous video we learned how to use brain.js. It's another node.js library to perform machine learning and deep learning within node.js. So today we're going to talk about TensorFlow. TensorFlow.js is the implementation for JavaScript and TypeScript within Node. It's a little bit of the counterpart of TensorFlow within Python. It has the same structure and the same things that can be done, but then within Node.js. So for that, I'm going to install TensorFlow with tf.js node. Right. This will just install tensorflow.js in our project. Now it's going to build TensorFlow Node.js bindings within C++. And now it's done. So now we have TensorFlow installed. If you have an NVIDIA card that's been CUDA enabled, you can use tf.js node GPU to run your code on the graphical processing unit, because it needs to do a lot of operations with vectors. So that's why a graphical processing unit or a graphical card is ideal for that, but it needs to have CUDA on it. Again, on the TensorFlow website you will find some more info about GPU support and what you need to do to see if you are or have NVIDIA card with CUDA enabled. So first of all, we need to use the import tensorflow/tf.js. We are going to use here for tf, and we're going to import tensorflow/node. Great. So now we're going to prepare our data. For that I need to do const inputs. I'm going to copy this and park it a bit further because we're gonna need that for our outputs, right? For my inputs I just need to have this, this, so you see it's a little bit, it's structured differently. So these are my inputs, then I need to configure a const outputs. Great. I know that we need to create tensors out of it, so we're going to do that. I know we're going to create tensors out of it, so I'm going to do that. Now we're going to define our model, tensorflow.sequential. Alright, I'm going to remove this code. Okay. So now we can define our input layer. Then I'm going to define a hidden layer with 10 hidden neurons. And an activation of ReLU. And then we will have one output, which is CMOID. If I now do model.summary, if we now build this, and we look at the result, we'll see that he prints out what the model is and how it looks like. Right. So next step is adding a model.compile. We will use the optimizer RMS prop. We will use not categorical but binary cross entropy, and we will use the metric accuracy. This RMS prop is just an optimizer. You can also use Atom or other optimizers. For that, you just need to read the documentation, right? And for the loss, we choose binary cross entropy because we just have one output. But when you have multiple outputs, you need to go, and so you have also multiple categories you need to choose for categorical cross entropy. So the last thing that we need to do now is just define our batch size. In our case, we're gonna use a batch size of 1 because we have a very small input data set, right? And normally you're not gonna use a neural network for that, but just for this video, I just choose a small data set just to show you how this works. Then we have our train epochs. So in this case, I will use, for example, 20 or 25, doesn't matter. And then here we have our input tensors, our output tensors. We have our batch size, which is 1 in this case, but normally when you have a bigger data set, we will use a larger batch size, right? So then he's just going to go over your entire network, and when that batch size is completed, so the number of amount of samples that neural network saw, he will recalculate the weights again. So now we just gives him one data sample, and he's just going to recalculate the weights again. But like I said, when we have a bigger neural network, a bigger data set, a bigger input tensor, we will choose also a bigger batch size for that. Also for the train epochs, you just need to see how your network is react upon that. So the train epochs is how many times a neural network will see the complete training set. So for that, I'm just going to build our application here. And I'm going to execute it. You see it's now training it, and we have an accuracy of 50%. So when we change now, for example, the batch size to 4, which is the complete size of our input tensors, and we just build this, now we execute this, you will see that we get an accuracy of 1 or 100%, right? So that's great, but that's because he just saw the complete batch size, and he just can recalculate upon that and adjust the weights. So our model is maybe too correct, too good to be true, right? But again, it's a very small data set. It's just for showing you what possibilities are. I hope you learned a lot. Please subscribe to my channel, and I will see you soon. Thank you for watching. Bye.